All right, let's go over quiz 5, which is over logarithms. So this is quiz 5. Let's look at number 1. Number 1 says graph y is equal to log of x. So we've already graphed the log on the last one. This log is a special log. Notice that it doesn't have a base. Whenever log does not have a base, it is because it is the special log. This is called the normal log. And it actually does have a base. The base is a 10. So this is the same thing as graphing y is equal to log base 10 of x. And as we should know by now, this goes to the point 1, 0. It also goes to the point base 1. And then we can also use the point 1 over base negative 1. So these are the most important ones. 1 and 0 is going to be right here. Base and 1, the base again is 10, so it's going to go through 10, 1. And this was kind of hard to graph, but we also know that a logarithmic function has an asymptote right here at x is equal to 0. So it looks something like this. Okay, that is the graph for log of x. This one right here, find the inverse of y is equal to 5x to the fourth. There's an example on this one on the first quiz. So we're just going to go through it really quick. So all this is that you're supposed to recognize that whenever I have an exponential, the inverse turns out being a logarithmic function. So right here, the inverse just means switch the x and the y. This is going to be x now. X is equal to 5 to the y over 4. Now, this is already the inverse, but if I want the inverse function, this means that y has to be by itself. Y is equal to something. We have to solve for y. The way we separate y from the exponential slot, we have to write it as a log. We're going to rearrange it. So how do we rearrange as a log? Well, after log, you write the base, which is 5. After that comes the result, which is x. And then at the end is the exponent, which is y over 4. Now we're one step closer to getting y by itself. All we have to do is get rid of the 4. How do we get rid of this 4? Well, it's divided by 4. So the opposite of that is multiplying both sides by 4. So then I'm going to end up with y is equal to 4 times log base 5 of x. And that is your final answer. Notice that the inverse of an exponential is a logarithmic. These two are opposite to each other. Number 3, rewrite the exponential as a log or vice versa. So over here we have m to the n is equal to 22. When we rewrite it as a log, this is going to be log with the base right here, which is m. M is the base. After that comes the result, which is 22. And then at the end comes the exponent, which is n. This one as, this is a log, so we're going to write it as an exponential. This one, the base here is a 2. The exponent is here, the x, and this is equal to the result y. Okay? Number 4. This one, if I change the graph of 1 to y is equal to log of x plus 2, describe the transformation. So what was the equation for number 1? Number 1, which is y is equal to log of x. And this one is really easy to show because log is already a button in your calculator. So when we look at this one, we can go to y equals. And first we can do log of x. So this is the log button, log of x. That's how log of x looks like, right? It goes through 1, 0, and 10, 1. Now let's see what happens when I do x log of x plus 2. So this is super simple. Log of x plus 2, parentheses. So what is the difference between this one and that one? Well, if you look really closely, this moved to the left 2. And I just want to point out that in your calculator, it shows that it stops right here. But the logarithmic function does not stop there. What happens is there's an asymptote right here. And this is actually does come through here. Oh, let me try to do that a little bit better. Goes through there. Okay? So that is what the logarithmic function, the solid line, that's the log of x plus 2. So what happened between the first one and the second one? This made it go to the left 2. And that is something that we covered in class. Whatever number is right here next to the x is actually going to move it sideways. Whatever the number is actually going to be opposite to what you think This plus 2 is gonna make it go left by 2. If it was out here, if it was a plus 2 out here, it would make it go up and down. So for example, if I had another plus 2 out here, this will make it go up or down. Positive actually goes up, negative actually goes down. Okay, so I'm gonna take that off because it wasn't part of the equation. Identify the new domain and range. So let's look at the calculator again. And we're gonna look at the domain and range. The domain is all the x's that are present. So we're gonna look at the function like this. Okay, so you notice that there is no function out here. Why is that? Because there's an asymptote, right? The function only exists from here to the right. How do we write that? The domain is all the x's greater than what? Where's my asymptote? -2. So the function is only to the right of the -2. What about the domain? The domain is when I look at it like this. Let me put it somewhere else. Oops. The domain is when I look at it like this, right? So does my function cover all of the y's? Do all the y's are all the y's part of this function? Well, you can tell that this one's going to go down forever. This one, it looks like it's going flat, but it is increasing, and it is also going to go up forever. So all these y's, any y you can think of, is going to be part of the function. What does that mean? That this is all reals. All real numbers of y are going to be part of the range for this function. Okay? And that's all.